I'm Patrick Fenner. I'm the engineering director for DefProc Engineering. And I'm here to talk to you today about the development of a smart gas pressure sensor that's supporting the expansion of hydrogen in the UK gas network. So, DefProc Engineering is a design engineering company. We specialize in proof of concept, prototype, and design for manufacture, based in Liverpool in the UK. And we're there to be able to support clients with their projects as an innovation partner and allow them to deliver new projects and open new routes to market. So in terms of background for this project, where its importance lies, the UK has 23 million domestic gas connections used for cooking and heating across the whole of the UK. And together, they account for about a fifth of all of the carbon emissions. I've got 18% here. Read another one this morning that was 23. So about a fifth of all carbon emissions, which seems like a big number, but we can bring that down to make it a little more personal. I've got gas central heating, I've got gas cooking, so that means that my household produces 24 tons of equivalent of CO2 every year for basic things. That's warmth, that's food. And while there's some things that I can do personally to try and reduce that, it's not going to go away as a whole without changing the heating type or the gas type that's being used. So in 2021, the UK government came out with this hydrogen strategy. Lots of different uses that they wanted to bring hydrogen into as part of decarbonisation. Lots of industrial uses, but one of the things that they wanted to do was completely replace all of the natural gas supply in the UK with hydrogen supply to have zero carbon as part of that use. And their plans to be able to create or to be delivering 5 terawatts of gas to homes by 2030, the equivalent of about 3 million homes on supply, to get to a fully decarbonised gas supply by 2050 to meet their net zero requirements. But obviously the government isn't who actually delivers that. That's delivered by the gas network operators. And it's a huge project for them to be able to undertake with many, many parts. But it's not without precedent. The gas type has been changed in the UK before. So Northern Gas Networks, one of the 4 primary gas network operators, contacted us to be able to ask about a specific solution to a problem they were facing as part of that, for being able to monitor pressure as it goes into the homes and then be able to feed that back so that they got an understanding of what's happening at the home. The reason that's needed is because of some of the differences then between hydrogen and natural gas. A lot of things to do with them are exactly the same, and there's a huge amount of work going on at the moment in terms of the safety case for hydrogen to make sure that any hydrogen supply is not only as safe but is safer than natural gas as it's being supplied. And there are a load of network upgrades that need to take place as part of that. Actually, for the consumer side, it's relatively straightforward, other than some older appliances needing new burners. That's pretty much the only change that they'll make. But for the networks, they're investing a lot of effort in being able to make sure that consumers know what's going to happen. They've got, for NGN, they have 7 hydrogen homes that they've built in Gateshead in northeast England to be able to, as technology demonstrators, to be able to put some new appliances in there, some new technology in there, and be able to open that up and show people what it's like ahead of the expected rollout for the first hydrogen village trials, which is to take 2,000 homes and supply them exclusively with hydrogen, expected to be, again in the northeast, that's expected to be in Redcar. But whilst hydrogen and natural gas are very similar, some of their differences play into what's needed here. So hydrogen is less dense than natural gas and slightly lower energy density, which means it needs a higher flow rate. And the UK gas network is supplied at very low pressure, it's about 35 millibar nominal, which means that the network operators, as they're responsible for delivering the gas, want to make sure that they are able to supply the rates to maintain the pressures so that everybody's equipment works as normal. And one of the things they really want to make sure is if they have a problem with under pressure, that they can recover from that and make sure that people's supplies are maintained as far as possible. So for them to recover from an under pressure, that would mean sending engineers out to every single affected location, whether that person is on holiday, in the middle of a work call, or asleep in the middle of the night, and be able to turn off their gas supply, just bloop, turn the valve off, then go away and repair the network, make any changes, recover from that low pressure condition once the load is removed, and then go back out to all those houses again, knock on those doors again, and turn them all back on again and make sure that they're restored. So the ideal situation here would be that you get an automatic shut-off if the pressure drops too low, and that the network operator knows basically immediately that that's happened, because that means that they don't need the manpower to be able to go out and do that. They don't need the time to go and do that. But it means that they can start on any repressurization work immediately and just go around once, make sure everybody's safely turned back on and functioning as expected, and meaning it's nicer for the consumers, quicker to respond, and less cost for the network operator. In terms of that pressure monitoring then, we were asked to design a device to be able to monitor the pressure as it comes into that user's home, be able to report that remotely back to the network operator, and to be able to close an isolation valve to be able to stop supply, remove the load in the case of a low pressure situation. Obviously we need some kind of pressure sensor in there. We need an electronically controlled valve so that we can choose when that's open or closed. Some sort of radio connection in there. And because it's something that's going to be fit and forget and sending its data through, it needs to be able to last for months or ideally years at a time there. So spending a lot of its time asleep, but able to monitor that pressure continuously, wake up and be able to respond immediately if that pressure drops too low. And it also needs to be able to be deployed in the time scale and scale that's expected. So that's 2025 for thousands of units and potentially scaling up to one device per household going forwards. Now, I don't know how many people have seen a UK gas meter, but it tends to look something like that. Mostly, you don't get to see them. It's not important most of the time. You can see here we've got so supply on the bottom left with the isolation valve, a nice flexi pipe, an anaconda that feeds into a regulator, and then the big white box there, the meter, before it goes off into the user's home and into their appliances. But for almost every home, these are tucked out of the way somewhere. Lots of retrofits have got them in the back of a cupboard, underneath something. They're behind all the shoes, covered in dust. But even in new builds, they tend to put them inside meter boxes, half put into the wall. Or what they really like to do is cut a hole in the floor and drop it and sink it in. So we're limited in terms of the volume of space that we've got available. And also, they're going to be in really tricky radio situations if we're trying to radio out. In terms of this project, though, the solution we've gone to, unsurprisingly, will be LoRaWAN. But less important than the actual radio solution we've chosen is why did we choose LoRaWAN for that situation? So we need low power comms because we need long battery life. That fits nicely with LoRa. Primarily, it's recording information and passing them up. Primary uplink comms, also LoRa's strong suit. It's also got good penetration through walls, so knowing that these are going to be not high up and on the roof and easy to radio out from, they're going to be low down, they're going to be sat on the ground, they're going to be behind whatever a UK builder has decided to make a wall out of in the past. But also, we get a benefit because any gas deployment, any deployment of hydrogen gas supply is going to be clustered. So it means that whatever's happening, you're going to be putting tens, hundreds, or thousands of sensors out into one area. And whilst the UK was a little slower to pick up on this than some other countries, utilities have this land back of small portions of land where they already have power going to it, they already have comms for their own monitoring systems, and those locations are generally going to be fairly close to where those people's homes are. So it's ideal for that LoRaWAN gateway and LoRaWAN sensor development. In terms of the project as it sits at the minute then, we have completed the proof of concept for it, so that's using discrete components to be able to build up a functions-alike, if not quite looks-alike device. It's gone through its third-party testing at DMV in Groningen to confirm that we've met all the criteria for gas isolation, for monitoring, and for cut-off times, and the external notification of that. And we've moved now on to the integrated device prototype for it. As it happens, I'm right at the point right now where I'm specifying the LoRaWAN modem, so I'm kind of on a shopping trip here today. All that means that at the end of the project, we're on track for devices on supply in those 7 hydrogen homes then in Q1 2024, which puts us nicely in place to be able to be delivering in terms of the village trials in 2025. So yes, the project's nice, but also how does this really help? What are the benefits here for the end user for this? So primarily, easy to install, goes straight in line with the existing fittings, and is able to provide the network operator with near real-time updates for the gas pressures as they set. Unprecedented access to the information of what's going on right at the end of the network, the bits that the consumer really cares about, and the bit that they really want to do well at. But then being able to do that, not just in isolated locations, but effectively across all the homes in the network, especially as they change over. It's got that nice backup so that it has that automatic isolation in the unlikely event of any issues with the network. But if it does, the gas network operator gets immediate verification that that load has been reduced and knows that all of the affected homes are all ready to be pressurized and back on supply, so that the recovery for that can start immediately. And ultimately, the result for that for customers is fewer and shorter interruptions in gas supply, which is kind of what they like. Thank you.